Okay, Math 2, Section 3.5. Today we're talking about isosceles and equilateral triangles. In your groups right now, I want you to talk about the difference between the two, if you remember.
Isosceles is too. Yeah, because I just saw her.
Hey. So, as I walked around the groups, I heard most of you stating it correctly. Remember, as soon as I start talking, you should not be talking. Christian and Hayden, you guys are looking the wrong direction. Okay? All right, so isosceles is where
two sides are the same.
Two sides are the same, and equilateral is where?
All sides.
Very good. So, just real quick, we will write two congruent sides somewhere on your paper or in your books, and equilateral is all or three congruent sides. Okay, now you have a definition down there on page 156, but I kind of want to look at this together. Okay, so we understand that when they have a leg here with a single line and a single line, that those mean that they are equal, okay? These are called legs. The ones that are not congruent, that is called the base. Okay? Up here, it says the angle formed by the two legs. All the side conversations need to stop, please. Makes a vertex angle. Okay, so the vertex angle is at the top. You have two base angles in the bottom. I want to show you something. Okay, if you have these legs, if you were to make them into arrows, do you see how that side is pointing to this angle? And this side right here with this leg is pointing to this angle? These two adjacent angles, if you have two sides that are equal, their angles will also be equal. Okay? Will this angle be equal? No, not in an isosceles triangle. Okay, moving on. So at the bottom of page 156, you have that definition. I'm going to draw a picture here for you, and you can draw this to your side. Okay, so we have a triangle here. I'm going to tell you that this angle right here is 70 degrees. And this side over here is 5, and down here this is 8. I would like you to fill in on your paper the missing side links and the missing angles. Okay, so I'm going to give you about 30 seconds. You can do this. So just draw on your own picture. Okay, you guys should be about done now. Is there someone that would like to help me? Okay, Aaron. Good. So we know that this is also a 5 because these two are equal. Okay. Yeah, good. Okay, anybody else tell me something else? Okay, Nicholas.
The bottom right angle is also 70 degrees.
Good. This bottom right angle is also 70 degrees, and you know that because?
The other side is 75.
Good. If the sides are equal, the angles are also equal. Okay, and my last angle, who can explain how to do that? Okay, Spencer. 70 plus 70 equals? Okay.
Shh. 180 minus 140, 43.
Good, and then you take 180 because all triangles equal 180 and you subtract it and you get 40 degrees. So this angle right here is 40 degrees. Okay, does anybody have any questions there? Okay. On page 157, they have a proof written for you. But this is not normally how we write our proofs. So on the right side, I would like us to go through writing the proof. Okay? So they have it written out like this, and we usually do our statements and reasons. So we're going to do that to the side so that you have an example of how we would normally write these. Okay, so what is the first thing that I always write? The given. We should always get this correct, okay? So we're going to write everything that's given. XY, line XY is congruent to XZ. And then it also says that line XB bisects angle YXZ. And all of that is given. So, based on what is given, they said that these two sides were equal, which were already marked. And then it said that line XB bisects this angle YXZ. So what does it mean when something bisects it? It makes them congruent. Good. It makes those two angles equal, right? And it makes those two congruent. Okay. So this one was already given, but when they said that it bisects, it didn't say that these were congruent. So we need to state that they're congruent. So we're going to just write that as angle 1 is congruent to angle 2, and what would be my reason? We knew that based on what information? Good, definition of bisector. It's actually angle bisector. If you just put definition of bisector, though, that works. I'll accept it. Okay, how many pieces of information do I need in order to show triangle congruence? 3. How many do I have? 2. What else do I know? Good, reflexive, right here. So line XB is congruent to line XB, and we know that by, very good, reflexive property. Okay, so now that I have 3 pieces of information, then we state what? Triangle congruence. So that's when we just write our triangle congruence. Triangle YXB is congruent to what other triangle? How do I say it? ZXB. And that is by what method? Very good. Side, angle, side. Is that what they asked us to prove? No. They asked us to prove angle Y is congruent to angle Z. And what is that reason? Good. Which stands for corresponding parts of congruent triangles are congruent. Okay. Questions? Okay, moving on. We're moving on still to page 157. We're still here. And you have this converse isosceles triangle theorem. What does converse mean? Good. Converse means the opposite. Make sure you're writing this stuff down so that when you go back and look at it, you'll know what we're talking about. Basically, what are they meaning? Originally, if you go back to the original isosceles triangle, they were talking about the what? The sides. They're saying the converse. If you have 2 congruent angles, then that means that the sides are also equal. So it's just saying that you can go back and forth. If you know the sides, you know the angles. If you know the angles, then you know the sides. Okay. So moving down here to problem 1 and got it. It says, we're going to read this first question, okay? Is WVS, so here is WVS, so it has this little angle right here. Is that congruent to angle S? What would we say, yes or no?
Yes.
Those of you that said yes, how do you know? Okay, good. Aaron just said that if you look here, do you see how this side and this side, they both have single lines? Okay, so my answer is yes. And the reason is that WV is congruent to WS. Therefore, angle WVS is congruent to angle S by the isosceles triangles. Isosceles triangle theorem or whatever. We're just going to put isosceles triangle. Are we good with that? Okay, so now the second question. Is line TR, so here's TR, is that congruent to TS over here? So in your groups, say yes or no and why. Talk to each other, see what you guys think.
Yes. Because both of those are happening. So that means minus.
Okay, the answer is yes. Now discuss why it's yes. I appreciate how most of the groups are actually talking about this. There's a couple of you that are not. Okay, here we go. I'm going to help you out here. We know it's yes because angle R and angle S, angle R is congruent to angle S. Therefore, TR is congruent to side TS by converse isosceles triangle. So remember, if we know that the two angles are equal, then we know that those two opposite sides are also equal for isosceles triangle. Okay, if you forgot to write converse, I probably wouldn't mark you wrong as long as you had that it's with isosceles triangles. So isosceles triangles, again, we know that if your angles are congruent, so are your sides. If your sides, so are your angles. Okay, do we have questions before we move on? Okay, page 158. Okay, VT. Okay, we want to say, what is that congruent to, and how do we know it's congruent? Okay, VX is correct. It is congruent to VX. And how do I know that to be true? Okay, because I know that angle T is congruent to angle X, which is by, therefore, or we can just put, let's just do a colon, converse isosceles triangle. Okay, do the next one. So here is UT. This is congruent to YX, and what else? UW. How do we know all of that? Angle T is congruent to angle W is congruent to angle X, which means that we are using which theorem? Converse isosceles triangle. Okay, because if we know the angles are equal, we know the sides will also be equal. Okay, questions? And we're only doing part of those, as you can see. We're not going to do all of them. Okay. Can I change the page? Are they equal? Is that what somebody's asking me? It depends on if you're talking. So this, when you're talking about, if you said sides are equal, it's just that equilateral triangle. But if you're starting with the angles and proving the sides, then that's converse. If you're starting with the sides, it's regular. Okay. All right. Okay, we are still on page 158. So read this little paragraph right here. Okay, so what is it stating? So basically, if a line bisects something, it is making a perpendicular bisector. When you have a perpendicular bisector, it makes 90-degree angles, and plus it makes those two congruent, those two pieces congruent. Okay? Now, there is multiple ways of solving this problem right here. Okay? So I want you to look at it. It tells you here, though, in there, that measure angle A is 27 degrees. So this right here is 27 degrees. What else do I know? Very good. Angle C is also, what was it?
27 degrees.
Thank you. Okay, based on that information, Stephen, what would you do next? Okay, so Stephen just said that D, because it's a perpendicular bisector, it's bisecting. We know it's bisecting because those two are equal. And that means that it makes these both 90 degree angles. Okay, there's two ways of solving this at this point now. What is one way of finding out what X is? Madison. Okay, that is one way. You could go 90 minus 27. Do you know how Madison knew that? Because if this angle is 90, then these two angles also have to equal 90. And so you'd have to borrow, subtract, and that makes it 63 degrees. Okay, does somebody else know another way? Holly. Yeah, so you could do 27 plus 90 plus X equals 180 and solve it that way. Okay, there's a third way. What?
They said there were only two.
I thought there's only two, and then Madison reminded me of another.
Could you do side angle side?
Not to figure out your missing angle. Like, so how could I figure out the X? Somebody else know another way? Okay, the last way is that you could do the whole triangle. 27 plus 27 plus X equals 180. So all three ways will get you the answer of 63 degrees. You decide which way you want to write down to remind yourself. Because you see what I mean by the whole triangle? How I could take this angle and this angle and this angle? And that's how I had x and x, because if that's x, that's x. Okay? All right. We're going to do this, numbers 5 and 6, and then we are going to stop for today. So when you turn, this is now to page 159, right?
Yes.
Okay. Say that one more time. Okay. Let's look at just x. Let's solve for x first. In your groups, I'm going to give you about 30 seconds. Okay, I'm going to pull a stick for somebody to help me solve it. Okay, Steven, help me. Okay, wait, before that, could you, okay, so you decided, no, that's not going to work. Okay. Somebody else, can somebody tell me how to solve this? Okay, Aaron. How did you know that's 50? Because of the congruent sides. And then how could you find x? Good? 50 plus 50 is 100, and then? Good. And so x equals 80. Do you guys know why I'm not writing 80 degrees? Not that it's that big of a deal. But since x, it says x degrees, we'd plug in 80. You wouldn't have degrees twice. No. Okay, now y. How do I find y? Okay.
Y equals,
Stacey, you're going to help me next. Hold on.
y equals 40
How do we know y equals 40?
because it has to equal, 80 degrees since both sides are congruent.
So you do 180 minus 100 and get 80, and then Nicholas, you divide it by 2 to get 40. So y should be 40. Okay. Now, number 6 is a little bit more complicated.
When you subtract 180 from 110 to get y.
Okay, Holly has the first one. Well, actually, that's not exactly it. But,
I mean 360.
well, hold on. So we know all straight lines equals how much? So 180 minus 110 equals what?
70 and then divided by 2.
Well, hold on. So if that's 70, do you see how these point to the sides, you guys? This is what I'm talking about. This line points to that angle, which means that this line points to that angle. And since these sides are congruent, then these angles are congruent. So how much is y? 70. Now how do I find x? Good. 180 minus 140 is 40. So in this case, x equals 40.